Hi, welcome to Product Review by RoboJax. My name is Ahmed Shamshiri. In this video we are going to do the review of this so-called plasma speaker or a Tesla coil that needs 24 volts and without speaker either from this jack. You can inject music or via Bluetooth, so it can play music with some spark effect at the top, and we're going to see how it functions. We're going to test it with different bulbs. Some 12 volts bulb from the car, and I'm going to test it with all these bulbs. With these 7-segment displays. Input current when I turn this on, input voltage signal at the primary coil. Let's measure the resistance of this coil. This is a very dangerous device. So be careful. This can be very dangerous. It can cause fire or burn your fingers. So let's get started with this. You can get the data sheet and other files related to this by clicking at the link below the video in the description, which will take you to robojax.com/learn/Arduino. Let's get started with this. So I give you a warning that this is very dangerous. It might harm you. It can burn your skin or fingers. The experiments that I do here in the lab are very dangerous. Do not try them at home. This can be used just as a speaker, but be careful that the children and people should not have access or get close to this, because they will get either burn or they will get shock. And these are the spots that my finger was burned when I got it closer to this plasma speaker. To attach this, make sure that green is on this side, this tip on top of this, so it goes very closer in here, and the secondary winding is inserted into this primary winding. I just bought this to have fun and create some decoration on my table, and also we have some lights here, blue lights at the bottom, which makes it very nice. Very delicate design, and you can present it like a science project or something on the table, but put a big sign beside it saying that danger, so people should not play with this once it is turned on, only people who know. So this is a plasma speaker, meaning it doesn't have any diaphragm. We have a mechanism here that you can inject an audio from an audio source or from Bluetooth, where you can select it by this switch. So this switch has 3 positions: off, and then this is input from the headphone type jack, and if you put it in the last position, it will be through Bluetooth. It has a Bluetooth module, so you can send music from your tablet or whichever device you have, and it will create waveform based on the signal that is in audio. And this is also called ionophone. Search for plasma speaker, and on Wikipedia we got this, that it says it's called plasma speaker or ionophones, that are form of loudspeaker which varies air pressure via high energy electrical plasma instead of solid diaphragm. The plasma glow discharges like coronal discharge or electric arc, which acts as a massless radiating element, creating impression of wave in the air, and listener perceives it as sound. I will provide you the link for this. Different pressure in air. It's not as clear in the speaker, but you can, at a certain point, you can understand and get the music or the beats. This is a primary coil here. If I open it, for the in terms of transformer, as you can see, this is a primary coil. I'm going to open it and show you, but it starts from here, 1 turn up to here, and then 2 turn, and it's almost 2 3/4 turn in here, and here we don't know how many, perhaps these are in thousands. So whatever voltage we have, it will be induced on this, but very low current. And first pole is connected in here, and we have winding, and the last pole is in here for the secondary. So this is acting like a transformer primary, and that is a secondary winding. And here, if we assume this between pin 1 and 4 as primary, if this is 3 turns, this is 4 turn, and this is 4,000 turn, it will be 1,000 times more voltage. So 24 times 1,000 will be 24,000. This is just an example because I don't know the number of turns here. Because of the high voltage from the ground, from this point, we will have ionization. All this air will be charged with the high voltage. With the music, it will be turned on and off, and it creates pressure on air, so we will hear music. But because the voltage is very high, if you bring a device here, through the air it receives energy and it will be turned on. Of course, it will not be turned on fully, but we will see some effect. It will be very bright. Other than that, we have no circuit diagram for this. I bought this from eBay, from this store, for $63 with free shipping. Now let's open the box. We have an audio cable here, male to male. We have a power adapter that is rated 100 to 240, 24 volts, 3 ampere. And we have these 2 pieces. Very well built. Nice. And this is the coil where the first wire, one pole is here, the other pole will be created by air with this tip at the top. Attach this, make sure that green is on this side, tip on top of this, so it is longer, very closer in here, something like this. So this portion is done. This is a power jack where you can connect it to the provided power adapter of 24 volts. And here we have also a fan that is cooling this down. You can connect it to your phone, and you can inject the music from this jack. Now let's open this and see what's inside. These 3 are acting as wire, as a connection, so with 3 standoffs, I have to remove that. And here, so this stage has only these 3 connections that comes to it. One wire comes here, goes to this coil. From this side it goes back. From here, from the bottom, it comes to here and then rotate and it goes back. So these 2 are for the main primary coil. I cannot remove this unless I desolder here, remove the solder from here and from here, from these 3, and remove the solders for the this fan wire, because these transistors have been soldered there, so I have to remove it in order to have a look at this. Switch.
Bluetooth mode.
Now to connect the Bluetooth, let's just turn off the Bluetooth and turn it on. And this is the one, GIA M02. Let's just touch it and you will see that now it got connected and sound came from this. This is the ad from YouTube. We can hear it. We are hearing it now from this speaker. So it's coming from that Bluetooth. If I put the music here and the music is available on YouTube, the YouTube will block this video. For that purpose, I cannot put here music at the background so you can hear it. The width is 84.6 millimeters by 84.6, so this is fully squared. This area is 60 millimeter. Length of the coil is 104.8 millimeters. Diameter of the coil is 25.7 millimeters. Total height is 20 centimeter or 200 millimeter, around 7.2 inches. If you want to know the weight, it is 224 grams. Now the first test that we do, it would be that 12 volts bulb. This is from the car. I just connected these wires. These will not have effect because this area should be exposed into the magnetic field. Let's see. You can see it. And here, this is the scale of the spark. And here I have connected the phone via this wire to the input. I'm going to turn off the light and play this music. When I turn this on, it will interfere with my microphone, so I will not be able to speak. Now let's have a look at the thermal image. And here, 105, 112 degrees Celsius. So This was included with this kit, this LED and also this LED. We test them. I have these 4 LEDs on breadboard. I'm going to test it with this as well. As you can see, they are turning on. Amazing. This bulb, tungsten bulb, 110 volts. Ooh. Bring this closer, this will turn on. When I bring the fluorescent closer, you will see the amount of energy will be reduced. So be careful. So these two will give you a shock. This is the power from this side. If you touch this or this, you get a shock. Not a shock, it feels like burn. Now I'm going to test it with these 7-segment displays. I start with the smallest one. This is 0.56 inch. And this is 4-digit, and this is very large. Let's see how this turn them on. As you see, when I rotate it, different segments will turn on. It's because different segments wire will come into the field, and that's why it will turn on. And now pay attention, because this is large, perhaps the wires that are here, they are being exposed more to the field, and this will turn on brighter. Now let's test this type of LED bulb, and this one, you see the shape is a little different, two different brands. And also this is LED. I'm going to test this as well. This is also LED. Now let me show you how much this is affecting when I turn it on my computer here. This computer screen, I'm using it with a touch to select different inputs. For example, top camera, my editor, my second camera. And when I turn this on, pay attention what it does. It is continuously clicking and moving the cursor. It brought already the keyboard. See that? Let me get this wire here closer. And we're getting this arc. I've bent this wire here like that, and two wires. You see it creates smoke. It burns the varnish around the wire. Now let's measure the input voltage for the device. As you can see, it's 24 volts. And here if I do the continuity test between this point and the external wire, so this is all ground. And if I do it between these wires, the primary one side and the other side, they're not directly connected. Let's measure the resistance from this side and the tip. "25 ohms, 25.2 precise." Now I'm going to measure input current when I turn this on. Because of my microphone, I'm not going to talk, but what I'm going to do is I'm going to measure the current while this is on without any load or disturbance. Then I'm going to bring the bulbs closer and see if the amount of current changes. Let's turn it on and see if I connect oscilloscope what happens. So my oscilloscope is now, this is what we see without even, so they are just further away, and let's see. And we are getting, and as you can see it shows 3.37 megahertz. While this is on, I've connected one wire of oscilloscope to the one wire of primary to this point, and the signal I'm going to connect it in here, and this is the signal of the primary coil. Again, the frequency is 3.3 megahertz. You can see the primary voltage is around 8 volts peak to peak. So for conclusion, that I would say is that be careful. As you can see, when I was bringing a tungsten bulb, it created this spark, and here still the device is functioning. Spots that you see, these are because of the spark. So there is a plastic layer, the plastic was burned. This is due to spark, these as well. Be careful with this. This is very dangerous. If you want to use it, you will get shock, you will get finger burn, your skin will burn when you touch it. So definitely this is a very dangerous device. If you want to use it just for music or for something in a cold, there should be a barrier. It should be inside a box, glass box, and nobody should get close to this when it is turned on. So I just give you the warning. Thanks for watching. This was the demonstration of plasma effect of Tesla coil with this 72 watt. If you learned something and found this useful, please thumb up, as this will help my video in the search algorithm of YouTube. If you have comment or question, please post it at the comment section below. I try to answer and reply. And don't forget to subscribe so you get updates of my upcoming videos. Canada, we have this ball. Let's see, we have audio cable that you bring music from your mobile device or whatever device you have. This is the actual coil with thousands of turns in it. And this is the kit that we are going to start building it.